Today's video is about writing conclusions using the CERE method. Instead of answering a series of questions, you'll write about 4 to 5 sentences. So starting at the beginning, each lab starts with a question and your answer forms the hypothesis. For example, what type of surface has the most friction? That's your question. Your answer may be, well, rubber has the most friction. That would be your hypothesis. Or another question for a lab would be, what variable affects our time to text a message? Your answer may be a guess, but it is still your hypothesis. When I text a 140 character message, I take 3.2 minutes. Now we get to the conclusions. So starting with C, which stands for claim, this is a statement that answers the question being investigated. If your hypothesis is correct, you can use that. Or you can use a blank caused blank. So whatever the independent variable caused the dependent variable to change. Or finally, a statement that explains an important point learned from the experiment. You can check with me in terms of something that you might have learned that you didn't expect from the lab, and that can be the formation of your claim. Next up is E for evidence. So this is data from the lab that supports the claim. Please do not write, look at my data table. Instead, you're going to pull data from the data table and rewrite it here. Not all of it, just some of it with units, and explain that data and how it affects the claim. So if you think that rubber has the most friction, you would need to have the name rubber plus the force for friction, maybe it's 5 newtons, and a comparison to that would be cork, and cork would have less newtons, so 3 newtons. Looking for about a sentence here. So I wrote down specific numbers with units, or it could be qualitative, meaning words, like let's see, something that's qualitative would be like blue or green, colors, or something not quite as descriptive as numbers, like bigger or smaller. Next up, we have R for reasoning. So this is the toughest part. This justifies the link between the claim and the evidence. It explains why your claim is true. You want to look to your notes or the textbook for scientific principles, laws, and theories. This can be kind of tricky, but it is the most important part of the lab. And finally, it could describe part of the procedure. Finally, we get to the second E, which stands for errors. And notice that it's plural because you have to find 2 errors. So state 2 ways the data may be inaccurate. These could be measuring errors. Now, the words human errors are not acceptable as an answer because people are not errors, but we do make errors. So if you're specific, then you'll get the points. For example, measurement errors of using a ruler is an error, but you have to be specific. And you can say there was a measurement error at the end of the ruler, and that affects any distance measurements you took. Letter B says maybe something that should have been tested or was tested incorrectly. So if you'd like to test something different that wasn't available, or maybe this simulation didn't include certain variables like friction, you could reference them here. You just have to have a total of 2 things for the errors. They could be one from A and one from B, or both from the same category. So that's our video for claims, evidence, reasoning. Please see me if you have any questions. This is important. I wish more people used reasoning to explain their claims.